Have you ever really thought about what's going on inside your phone charger, or your laptop's power brick, or even your car? Well, there's this invisible force, a quiet revolution in power that's been happening right under our noses. It's the reason all our tech is getting smaller, lighter, and just way more efficient. So today, we're going to pull back the curtain and take a look at this hidden power revolution. All right, so here's the game plan. We're going to start by looking at the big problem with power. I mean, how we used to waste so much of it. Then we'll get into the brilliant idea of a more efficient switch. Check out the tiny little components that make it all happen, see how it's literally powering our entire world, and then we'll get a sneak peek at the next power revolution. Okay, so to really get why this was such a huge leap forward, we've got to go back and understand the problem. And it was a problem that stumped engineers for decades. We were just wasting massive amounts of energy for no good reason. And it all starts with a question you can probably relate to. I mean, do you remember those giant, heavy power bricks from back in the day? The ones that felt like they weighed a ton. Well, the reason your phone charger is so tiny now, that's the whole story right there. See, the old way of doing things was basically brute force. The best analogy is this. Imagine you want just a trickle of water from a faucet. Instead of turning the knob just a little, the old way was to turn the faucet on full blast and then try to block most of the water with your hand. That's what these old power supplies did. They'd pull in a ton of electricity from the wall and just burn off everything they didn't need as heat. And that was the crazy part, the fundamental flaw. They were inefficient on purpose. It was baked into the design. A huge chunk of the power that old brick was pulling from the wall, yeah, it wasn't even going to your device. It was just making the room a little warmer. What a waste. So how do you fix a problem like that? Well, the solution was one of those simple but absolutely brilliant ideas that just flips the whole model on its head. And it all comes from a field of engineering that honestly, quietly changed everything. And that field is called power electronics. The big idea here is that you stop trying to burn off extra energy. Instead, you control it with incredible precision. And you do it using these amazing little devices that act like lightning-fast switches. And this right here is the total game changer. Instead of burning off that waste heat, these power electronics act like an insanely fast light switch. We're talking about flicking on and off thousands, sometimes millions of times per second. They chop up the electricity into these perfect little packets and deliver only what the device actually needs. The result? Almost zero waste. And when you have less waste heat, you can make everything smaller, lighter, and way, way more efficient. You know, the whole revolution really came down to just a simple shift in thinking. The core principle says it all. The transistor is now operated as a switch, either fully on or fully off. So instead of being like a leaky, half-open faucet, it's now a perfect, clean light switch. It's either on or it's off. And that one simple change, well, it made all the difference. Right, but switching power on and off millions of times a second, that is a very demanding job. It's not something your average little component can handle. To actually make this work, engineers needed a whole new toolbox filled with specialized switches that could handle some serious power. And when we say switches, don't picture the billions of tiny, microscopic transistors inside a computer chip. Nope, these guys are the heavyweights of the semiconductor world. They are big, beefy, powerful devices built for one single purpose: to control a massive flow of electricity with absolute precision. So one of the early workhorses in this toolbox was the thyristor. You can think of it like a digital circuit breaker. You hit it with a tiny little signal, and bam, it turns on. And once it's on, it's latched on, letting a huge amount of current flow until you reset the whole system. These things are incredibly tough, perfect for those really heavy-duty jobs. Then a more modern hero came along, the IGBT. Now this one is kind of the best of both worlds. It can handle all that high power, just like the thyristor, but, and this is the crucial part, you can turn it on and off super, super quickly. And that rapid, controlled switching, that's the secret sauce that makes all our modern electronics so darn efficient. Okay, so we had a big problem with waste, and we found an amazing solution with high-speed switching. Now let's talk about the payoff. Let's see how this one single idea has completely reshaped, well, pretty much everything. So where is all this stuff? The short answer, absolutely everywhere. It's inside your refrigerator, your AC, your computer. It's the beating heart of every electric vehicle and every subway train. It's the backbone of our power grid, our factories, you name it. It's one of those technologies that is truly hiding in plain sight. And if you want to get a sense of just how big this is, get this. Decades ago, engineers predicted that one day, more than half of all electricity generated on the planet would flow through power electronics. And guess what? That prediction came true. We are living in that world right now. And here's a perfect example of why this matters so much. Let's say you have a big industrial pump. The old way to control it was just to run the motor at full speed all the time and then use a valve to choke off the flow. Talk about inefficient. But now, with what's called an adjustable speed drive, power electronics can precisely control the motor's speed, giving you exactly the flow you need and nothing more. The energy savings are just massive. But the story doesn't end here. Not at all. As incredible as today's silicon-based switches are, the next great leap is already happening. Engineers are now looking at a whole new generation of materials that promise to take efficiency to a level we've only dreamed of. Now, of course, no technology is perfect, right? All of this super high-speed switching, it can create a side effect. It's basically electrical noise, or harmonics, that can sometimes mess with other things on the power grid. So the challenge now is to build even better, faster, and cleaner switches to minimize that. And the key to doing that? It's all about moving beyond the good old silicon that's powered the electronics industry for like half a century. We are now entering an era of new, advanced semiconductor materials. And the difference these materials make is just staggering. Just look at something like silicon carbide or SiC, and even diamond. These things can handle way higher voltages. They're incredible at getting rid of heat, and what that means is that the switches of the future can be even smaller, even faster, and way more efficient than anything we can build with silicone today. So all of this brings us to a really fascinating question. We've gone from power supplies that were literally designed to be wasteful to systems that are incredibly efficient. And as these new materials get us closer and closer to the idea of nearly lossless power, you have to wonder, what's next? What new things will we be able to create when wasting energy is no longer holding us back?